We were discussing about generator file development and write driver, read driver. Sorry, read driver. We haven't started. We have started with the discussion of what to say our write driver as well as generator, which we have seen in our previous session, right? Now, in this particular session, let's move forward and let's discuss about read driver. Okay. And yeah, before that, let me share my screen. And I also shared all the particular codes, EDA playground I have shared, right? So you can refer that particular codes in that. And yeah. So let me log in and give me a second. Yeah, sorry for that. Let me share my screen. So previously when we were discussing about interface, we haven't added any clocking block or mod port in that. So let's try to add those particular things in my interface file. In the interface, when I was declaring it, I haven't added anything. So let me add the clocking block for my write driver and read driver. So I'm going to first of all add the clocking block for write driver. Okay. So how I'm going to add that? I'm going to simply write down clocking followed by write underscore clocking block is my clocking block for my write driver, and it is working on the positive edge of the clock. Okay. Here I'm going to have the default skews, default input hash one, and output hash one. So these are the default skews which I'm going to have. And with respect to my write driver, I have the output signals as reset is one of the output signal. Okay, this is not an output signal for my write driver. Write enable is one of the output signal, and followed by address is output, and also you're going to have W data. This is also output. And apart from this, we are going to have the input as R data. Input is R data, and valid also it's input to your write driver. Okay, and clocking. So here I have given the directions, whatever the signals which are inputs and outputs. If you are new to this particular verification series and this is your day one, I recommend you to watch the previous sessions where first of all, please refer to the decoder-based RAM design using Verilog. Okay, and then go step by step, like go through the generator, transaction fund and all. Okay, and coming to the clocking block for my read driver. So clocking block for read driver. So coming to my clocking block for read driver, I'm going to declare clocking read underscore CB. Yeah. So I'm going to write down the clocking block for my read driver. So clocking read underscore CB, and it is also working on the positive edge of the clock, positive edge of clock. So here I'm going to uh, with respect to your read driver, read enable is only output. So first of all, I'm going to declare the skew, input skew and output skew, default hash one input and sorry, input hash one and output hash one. Okay. Now, with respect to your read driver, read enable is one of the input you're going to have. Okay. So I have read enable declared over here. Right? So this is output to my read driver. Output read enable is one of the output of for my clocking block, and also address is also output to your clocking. I mean for the read driver. And coming to my inputs, input I have R data and also valid. These are the inputs to my clocking read driver. Okay, and followed by end clocking. That's it. Now I'm going to have the clocking blocks declared for my monitor. I'm going to declare it for my monitor. For both the monitors, I'm going to have one clocking block. Let's say clocking monitor underscore CB at positive of clock. So here also let me declare the default skews. Okay, since it's sampling only, right? So that's why I'm going to have only input scale, right? And over here, for the monitor, I'm going to monitor every signal like write enable signal and read enable signal. And also I'm going to have the address as input as well as W data. And also our data is also input and value and followed by clocking. So if you carefully observe here, in the case of my clocking blocks which are related to my drivers, I was declaring the signal with respect to my test bench. Please observe over here. This is a very confusing point over here. Many get confused over here. You're not going to consider the direction with respect to the design, but you're going to consider the direction of this particular signals with respect to your test bench. That's the reason I'm giving this particular signals as output to my test bench and input to my test bench. Accordingly, I'm going to give this directions. Okay. And with respect to your monitor, the directions are being given. Okay. Is it clear, guys? So this is an often confusing point, like to which perspective we need to give the directions, whether with respect to our design or whether with respect to our test bench. This is a very important point over here. Is it clear? Shall we move forward? Yeah. Now, next I'm going to have my mod ports declared over here. Let me declare the mod ports. Mod port write underscore driver. Let's give the mod port name as write underscore drv is the mod port name. And here I'm going to include the clocking block name as write underscore cb is the clocking block name. And input is clock. Okay. And also I'm going to declare one more mod port for my read driver. So read underscore DRV is the read driver mod port name. Okay. And let's give it as read underscore DRV is the mod port name which I'm going to have. And I'm going to include the clocking block. Read underscore CB is the clocking block. And here for this also input is clock. And yeah. And afterwards, I'm going to have this signal which is write underscore monitor, write underscore monitor for this one mod port, and for read underscore monitor another mod port. Clocking block I've declared the same for this too, but mod port I'm declaring differently. Clocking write underscore monitor underscore CB and clock is input, and also monitor underscore CB and input is clock. So these are the mod ports which I've declared over here, and I'm going to use it in my design. So I'm going to use it in my design. I'm going to have it. Okay. Yeah. And followed by end interface, we have already declared over here. Okay. And in transaction, we are not going to use any mod port or clocking block. We are not going to refer anything. And in generator also, we don't need a particular clocking block or mod port. Okay. So where is your mod port is required? Mod port is required inside your write driver and read driver. There we are going to use your mod ports, not in your generator or your transaction or other things, right? Now let's go to our write driver. Write driver we have already written over here. Let me open this write driver file, which we have written over here. Yeah, this is my write driver file. Now I've declared my virtual interface, mailbox instances, and one of the int some variable for counting purpose, and a new constructor where the top model is going to give you the everything and reset us. This we have already discussed in our previous sessions also. If you haven't observed or if you haven't gone through that, I recommend you to please go through it. Okay. Now here I have given a particular construct at line number 229. I have given repeat of cycles. So this particular thing is going to repeat, but we need to give some clocking reference also, right? So here I'm going to use the clocking block. So I've declared in my interface, right? I'm going to use it at the rate virtual interface handle dot write underscore CB. So for this particular clocking events, my this particular reset n will be equal to 1 for that many number of cycles. Cycles here, it's a parameter we have declared over here. Wait a minute, let me show you where is cycles declared. Yeah. So here cycles is an argument which is four. So for four positive cycles or for four negative cycles, whatever the thing which we are going to give in the clocking block that we are going to give that we are going to have for that many number of cycles, it will be equal to one. Okay. And next we have a task which is known as drive task. Here also we are going to use a clocking block. So at that particular clocking block, we are going to drive our data. Okay. So at the rate VIF dot write underscore CV. This is already developed code which we have discussed it previously. I'm just adding the clocking block interferences. That's it. And here instead of having the raw timing, I'm going to have the clocking event. VIF dot write underscore CV. Okay. And yeah. And after that, I'm going to display. And in the run task, I'm going to call this particular thing. And in the run task, I'm going to call the drive task and I'm going to increment and all. This we have already discussed, right? Yeah. Any doubts or any queries in this about the write driver and the clocking block and the interface? Any doubts or any queries? So let's start with read driver in this particular session. Shall we move forward? Okay. Now, let's develop the read driver file. So let's see how to develop your read driver. So I'm going to have a simple class, which is ram underscore read underscore driver. Okay. And this particular here also, I'm going to have the virtual interface handle virtual ram underscore. Okay. Let me check the interface handle, which I've declared over here. Ram underscore if. Okay. So I'm going to have virtual ram underscore if and let me in the write driver also let me instantiate with let me refer to the clocking block which mod port which I've declared over here. So ram underscore if in my ram write driver ram underscore if dot the mod port name. Since I have declared the mod port now, right? I'm going to write down write underscore drv. I'm going to refer to the mod port also. Dot write underscore drv. Okay. Here also in read driver, I'm going to have read underscore drv. Read underscore drv. And the handle name is let's say VIF. Okay. And here the read driver is also going to expect two mailbox handles. One is mailbox of type transaction. Here, what I've declared the class name for transaction. Let me check it out. Transaction only. So I'm going to have the transaction class name. Transaction. And the mailbox name over here is read underscore mailbox, which is for read driver. And another mailbox as we have declared in our write driver also, right? So ram underscore transaction read underscore done underscore mailbox. This mailbox where I'm using, I will let you know when I'm discussing other particular monitors. I will show you. Okay. And another variable which is used for declaring, just for having the count purpose, txn underscore count. Okay. Let me check whether I've started recording yet. Now, after that, I'm going to have a new function new. So by now you might have got a clarity. This new function is used in SystemVerilog for getting the variables from your top level models like your interface. The best example is your interface. If you want to get your interface instance, that you are going to get it from your top model only. Okay. So mod port name VIF and also mailbox instances also you are going to get it from your environment, especially using your new function. And in your UVM, you're not going to use this new function for getting the interface or mailbox handles. You're going to use one more mechanism, which is known as config that we are going to see how we are going to use it and all, right? And rd underscore done underscore mailbox. So these are the two handles which I'm expecting and environment is sending them. Okay. Next, I'm going to copy it to my local copies. This dot VIF is equal to VIF and this dot rd underscore mbx is equal to mailbox instance and also done underscore mailbox is equal to rd underscore end function. So I've declared all the particular new function and I've copied them, right? Now, here I'm going to have a particular task which is known as drive task. I hope this is clear, right? This is straightforward and simple, right? Now, I'm going to have a task which is known as drive task. Same as my task which is present inside my write driver. Here also I'm going to have a drive task. So this drive task is expecting one argument of type RAM underscore transaction tx. So whoever is going to call this particular drive task, they need to pass this argument. Okay. And we are waiting for the clocking event to happen. VIF dot read underscore CB. We are waiting for this clocking block event. And if it is happening, then we are going to make our read enable is equal to 1. That means we want to perform the read operation. So how I'm going to write down VIF dot read underscore CB clocking block dot read enable is equal to 1 tick binary 1. So what are we doing over here? So whatever the read enable signal using whatever the read enable signal which is associated with your design, using the interface, we are going to make it to 1. Okay. And whatever the randomized address which we have randomized or which we have generated, which is present inside your transaction class, okay, which is present inside your transaction, that we are going to copy it to my interface. How we are going to copy? Txn.address is equal to VIF dot read underscore CB dot address. Okay. So what is happening over here? Whatever the randomized transaction which is present, that we are going to give it to the interface, and further we are going to give it to my design. Okay. Now, so after that, after providing my read enable and my address, I'm giving some time to perform the latch. Like DUT is going to latch this read underscore enable, and at the next clock edge, I'm going to collect my data. So how I'm going to collect my data? So at the rate VIF dot read underscore CB, I'm trying to collect my data. So how I'm going to collect? TXN dot R data is equal to VIF dot R data. Actually, we can collect the data in my monitor, but I'm collecting it in my driver itself. Okay, I can collect it in my driver. Okay, let's collect it in my monitor only. Why to collect it here? We have a dedicated monitor which is present there. We can collect it. Okay, so let's say after some time period, after VAF dot RD underscore CB, we will deassert this read enable and address. So how to deassert it? VIF dot read underscore CB dot read enable is equal to 0, and address also let's make it as 0. That's it. So we have made our read enable and address to 0. That's it. And after that, yeah, and followed by end task. Now, this particular run task, this particular drive task, we are going to call it in my run task. I'm going to have one more task which is known as run. Okay. This particular task is expecting a transaction handle ram underscore transaction tx. So using the mailbox, let's get the tx and handle. So how to get it? Within a forever begin block, read underscore mbx dot get of tx. We are going to get it from my generator. Okay. So generator, it is going to give the transaction instance to my read driver. After getting this particular transaction instance, we are going to call the drive task. Okay. And we are going to pass this tx. Okay. So that particular txn will be given to your interface. And from that interface, we are going to give it to my design. Okay. That is the process which we have done inside my write driver. So the same thing which we are going to do in our read driver. And also I'm going to have a count of my number of transactions which is happening. Txn underscore count plus plus. And followed by end and end task. That's it. So this is how I'm going to write down my code and followed by end class. That's it. Okay. The process is very simple. Read driver is going to drive the read related signals, and write driver is going to drive the write related signals. And in the write driver, since we have introduced our clocking block, let's write down VAF dot. Uh, what is the clocking block name for my write driver? Let me check it out. Clocking block name for my write driver is WR underscore CB. So when I'm driving the signals to my interface in my write driver, I'm going to use my clocking block since I've declared it, right? So let me write it down over here. VAF dot write enable dot address and dot data. Okay. Here also let me use the clocking block VAF dot clocking block dot write enable dot address and dot data. Okay. Yes. So this is how we are going to perform the driving operation from my write driver and read driver. So in our next session, let's try to understand how we are going to monitor the things, like how we are going to develop a write monitor and how we are going to develop a read monitor. Yes. Okay. Yes. Any doubts or any queries in this? When I go to same media playground link using code EFXU, I'm not able to see the updated code. Is this issue facing by everyone? Once please confirm, because I am opening this EDA playground code from the same group only. 1 minute, let me share the group